In April of 1943, occupied France was shrouded in bomb smoke and the roar of German squadrons. At an altitude of 27,000 feet, the air was so thin that every breath had to pass through an oxygen mask, and inside the cockpit of the Fw-190A5, Lieutenant Ralph Hermachon smiled. In the distance he saw silver dots climbing slowly from the direction of the English Channel, sluggish and heavy, trailing thin smoke across the crystal-clear sky. They were P-47 Thunderbolts from the 4th Fighter Group of the United States Army Air Forces, the newly introduced fighters making their first combat appearance in Europe. Hermachon switched on the radio, his voice tinged with mockery. "Die Army has sent us flying milk bottles." Below him, a formation of 16 P-47s struggled with altitude, their twin-stage supercharged Pratt & Whitney R2800 engines screaming as they fought through the freezing air. For German pilots hardened by survival over Poland, France and Britain, the sight was comical. They were accustomed to the sleek profiles of the Bf-109 or the Fw-190, fast, light, and instantly responsive to control. The P-47, by contrast, looked like a solid lump of metal, round-bodied with short wings and a massive propeller. The Germans mockingly called it the flying milk can. In the cold air of the stratosphere, they were confident, ready to begin their first hunt against opponents from across the Atlantic, certain that it would be an easy game. Since 1939, the Luftwaffe had flown through 4 major campaigns and crushed nearly every European air force they faced. They had dominated the skies over Warsaw, annihilated the French squadrons, and held the Royal Air Force at bay throughout the Battle of Britain. Those triumphs were engraved in the minds of their commanders as proof of the golden age of German engineering. Luftwaffe pilots were not merely academy graduates, they were tempered by real combat, with hundreds of flight hours and dozens of actual engagements. By early 1943, Germany still believed it possessed the world's finest generation of pilots, flying aircraft such as the Fw-190 Amperes and the Bf-109G, regarded as pinnacles of aerodynamics. When the P-47 appeared, that pride left them unworried. From bases in northern France, the JG-26 wing of the Luftwaffe took off with the spirit of hunters. Their 20mm cannon rounds were fully loaded, and the pilots were familiar with the hit-and-run tactic, using superior acceleration to dive, fire, and climb away. On the morning of April 8th, they assumed the encounter would end quickly. The American planes were too slow to climb in time and too heavy to dodge. German after-action reports recorded the words of Hermann Priller, commander of the 26th Wing. "The new American plane flies like a truck, turns like a freighter, climbs like a pregnant cow." The early numbers seemed to support that claim. In their first month of combat, the 8th Air Force's P-47 squadrons lost 14 aircraft, while shooting down only 3 Germans. The American pilots were inexperienced, most of them never having faced a real enemy. The Royal Air Force even mocked them, comparing the Thunderbolt unfavorably with the Spitfire and calling it the plane that needs its own runway to take off and its own hangar to turn around. In the pilot's bar, Tales of London, people joked that the best way to dodge bullets in a P-47 is to unbuckle your seatbelt and run around the cockpit. But beneath the laughter, something was quietly changing. Under the wings of that 7-ton aircraft were 8 Browning 50-caliber machine guns, loaded with a total of 3,400 rounds, unprecedented firepower for a single-engine fighter. When an American pilot pulled the trigger, the entire plane shuddered, and the dense stream of bullets formed a wall of lead, firing 100 rounds every second. Even when the Thunderbolt was clumsy, every hit was devastating. RAF observers began to note strange cases. P-47 seconds returning with riddled fuselages, even wings torn apart, yet landing safely. The R2800 radial engine proved to be an unexpected advantage. It required no liquid cooling system like the German V-type engines, rendering it nearly immune to bullets that pierced coolant tanks. When hit, oil and hot air leaked out, but the engine kept running, providing enough power to return to base. It was something the Germans had never seen. A Luftwaffe report from early May 1943 briefly noted, The new American plane shows unusually high damage resistance, apparently does not use coolant. Those remarks were still vague, but they hinted to German intelligence officers that the P-47 was no mere joke. Meanwhile, across the Channel, American commanders such as Hubert Zemke and Don Blakesley began drawing life-saving lessons. The Thunderbolt could not win in turning fights, but above 25,000 feet, it retained almost full power while German engines began to falter. Zemke experimented with a new tactic. Instead of trying to turn, his squadron climbed higher than the enemy, then dived at over 500 miles per hour, firing in a flash before pulling straight up again. This style of attack exploited the P-47's mass and durability, turning its once-mocked weight into a weapon. By mid-spring 1943, the air battles began to shift. American pilots started surviving more often, and the number of damaged planes returning safely rose sharply. They learned to trust the iron barrel they flew, to let its weight and firepower do their work. By June, the first combat reports showed that the P-47's kill ratio had doubled from the previous month. A pilot of the 61st Squadron wrote in his diary, "It is not pretty nor fast, but when you hit, whatever is in front of it disappears." The change was not enough to shake the Luftwaffe's confidence, but it was enough to silence their laughter. Ralph Herrmann, the man who had once called the P-47 a flying milk bottle, wrote in his flight log after months of battle, "We shoot many down, but they always return, more and more. Those fat planes seem never to tire." That brief note captured the quiet turning point of the war. In 1943, while the Germans still trusted in skill and experience, the Americans began proving that industrial power and persistence could rewrite the rules of the sky. From the early laughter, the air war had entered a new Phase 1, in which a once-mocked weapon was quietly gathering experience to become Europe's true nightmare. In the frozen heights of that spring, few realized that the encounter between Ralph Herrmann and the clumsy Thunderbolts would mark the opening of an entirely new chapter of war. The sky remained blue, but the smiles of the German pilots began to fade, replaced by unanswered questions about the strange weapon they had just faced. In September 1942, when the first P-47 was delivered to the Bridgeport base in Connecticut, it was expected to become the new pride of the United States Army Air Forces. But before it could see combat, a series of accidents plunged the entire training squadron into gloom. Within 4 months, 18 pilots were killed, and 41 aircraft were destroyed during training. An internal report from the 56th Air Force described the P-47 as a hard-to-tame machine, reacting violently under throttle increase and twisting unexpectedly during landing. It was called the American killer plane, with genuine fear, not as a joke. Lieutenant Colonel Hubert Zemke, commander of the 1st Training Group, wrote in his diary that it took him months to understand how to handle the aircraft. It weighed 1.5 times as much as the Spitfire, heavier even than the German fighters he had faced. Just pushing the throttle slightly beyond the set limit, the torque of the 2,000 horsepower engine was enough to flip the plane upside down. During landing, the landing gear could easily tilt, causing the plane to spin and break its wings. In those first weeks, the trainee pilots called it a metal traitor. More than a few left the training group out of fear, but those who stayed gradually realized one thing: if they could control that 9,900-pound block of steel, it was stronger than anything that had ever existed. Each time the supercharger switch was flipped, the P-47 roared, pressing the pilot hard against the seat. One officer described that feeling as riding a giant beast waiting for someone brave enough to control it. For many, the price of overconfidence was their life. When news of the 18th pilot's death reached headquarters, General Ira Eaker ordered a 3-day suspension of test flights for investigation. The report concluded, "The aircraft was not at fault. The pilots were not yet skilled enough." It was a harsh but truthful verdict. On June 26, 1943, the story of Robert S. Johnson changed the way Americans saw the aircraft they had once feared. That day, the 61st Squadron of the 8th Air Force was retreating to England after escorting B-17 bombers. At an altitude of 27,000 feet, they were suddenly attacked by 16 German Fw-190s from the direction of the Sunday. Johnson, at the tail end of the formation, immediately became the target. Within seconds, his plane took direct hits from 20mm cannon fire. One shell exploded beside the cockpit, shattering the canopy, and fragments cut his nose and leg. Oil and blood covered the instrument panel. Flames rose behind the cockpit. He pulled the canopy release to bail out, but it was jammed by a warped frame struck by a cannon shell. Trapped in the freezing high-altitude cockpit, Johnson kicked at the canopy repeatedly to no avail as the engine shook violently and smoke filled the cabin. He lowered the nose and tried to fly toward the sea. As the plane shuddered from oil pressure loss, another Fw-190 spotted him and dove in. Within minutes, the enemy emptied all its ammunition into the dying P-47. 4 20mm cannons and 2 13mm machine guns spewed fire, but Johnson was still there. When the German pilot ran out of shells, he flew alongside, rocked his wings, looked into the cockpit, and saluted half in disbelief, half in respect. Johnson was still alive. He brought the plane back to Manston Base, landing with broken landing gear and an engine nearly dead. Technicians counted more than 200 bullet holes on the fuselage, 21 cannon rounds through the wings and tail. One shell had exploded just behind his head, only a few inches away. The photograph of Johnson's P-47 after landing was sent to Air Force Command. The aeronautical engineers stood in silence. They found that the aircraft's frame remained intact, and the control system was still functional despite several severed cables. The R-2800 engine still turned despite losing one cylinder. The report concluded that the Thunderbolt's frame could withstand 3 times the punishment of other fighters. One pilot joked, "You don't fly it, you command a flying chunk of iron." Johnson's story spread quickly across the bases, and for the first time, those who had feared it began to believe this was a weapon that could save their lives. The reaction from the German side was completely different. The Luftwaffe command received reports from fighter wing JG-26 that a shredded P-47 had landed safely in England. German intelligence suspected propaganda. A technical officer wrote in a telegram to Berlin, "No aircraft can take more than 20mm shells and still have its wings attached." However, German pilots who had fought that day confirmed the truth. One recounted, "We saw the American plane burning, smoke rising, and yet it kept flying. When I ran out of ammunition, I broke off, thinking it would fall, but it did not." The truth left the German High Command unsettled. In meetings in July 1943, the term overbuilt design of the P-47 was mentioned for the first time. A technical specialist noted, "We miscalculated the firepower model. Our cannon shells do not penetrate deeply enough through the thick armor behind the cockpit." It was the first time the Luftwaffe reluctantly admitted that the aircraft they had scorned possessed survival capabilities beyond expectation. In Washington, a translated copy of this document was sent to the Department of Defense as proof of American design effectiveness. As Johnson's story spread, American pilots' confidence transformed rapidly. The P-47 seconds, once regarded as a burden, were now carefully maintained, and pilots began calling them "iron jug." From fear, they turned to pride. Technical reports stated that 60% of damaged aircraft still returned to base, the highest survival rate among all fighters at that time. Its durability began to shape tactical training. Hubert Zemke, who had seen many comrades die during the testing phase, understood the aircraft's true potential. In a tactical meeting with 8th Air Force Command, he proposed a bold idea. Instead of trying to fight like the Luftwaffe, force the enemy to fight like the Thunderbolt. He called it the energy fighting tactic, using altitude and mass to turn kinetic energy into a weapon. Zemke ordered his squadron, no low-altitude fights, no turning battles, no prolonged engagements. They had to climb high, then dive at over 500 miles per hour, fire for 2 seconds, and pull straight back up. At first, the tactic was doubted, but the results exceeded all expectations. In test battles over northern France, Zemke's 56th Squadron recorded double the number of German aircraft shot down compared to before. Pilot William Dunn recalled, "I felt like the P-47 was born to do this. Each dive shook the airframe with its own weight, but the enemy couldn't keep up. The same weight that had been mocked now became its weapon. While the Fw-190 could turn faster, the P-47 could dive deeper than any other aircraft. Each time they pulled back up, the black smoke from German engines faded behind. By the end of the summer of 1943, the boom and zoom doctrine was officially adopted. P-47 squadrons were systematically trained to exploit their speed and firepower. For the first time, the United States Air Force had its own distinct aerial combat doctrine, independent from British or French models. Over the skies of Europe, the roar of the double Wasp engine began to sound like a challenge. Those who had once called it the American killer plane now saw it as a living shield. The price of arrogance, for both American and German pilots, had been paid in those early months. For the Americans, it was the lives lost during training, the cost of learning that great power must be governed by discipline and reason. For the Germans, it was the collapse of absolute faith in skill. From the summer of 1943 onward, the skies of Europe no longer belonged to the most confident, but to those who learned from mistakes and turned fear into strategy. When the United States Army requested an interceptor capable of operating effectively at high altitudes, Alexander Kartveli, chief designer at Republic Aviation, responded with a proposal that broke every convention of the time. The XP-47B design and its subsequent variants were no longer light, agile fighters. They were machines built around power, durability, and firepower, a single-engine flying fortress, as the engineers who worked on the project described it. Its empty weight was recorded at 9,900 pounds, roughly 65% heavier than its predecessor, the P-43 Lancer. That figure translated into a stronger frame, a stiffer structure, and greater load capacity. This decision traded maneuverability for survivability and firepower, and that very trade-off defined the Thunderbolt's role in both production strategy and battlefield tactics. At the heart of the machine was the Pratt & Whitney R2800 double Wasp engine, an 18-cylinder unit rated at 2,000 horsepower. Yet the true game-changer lay in its turbo-supercharger system, a device that used exhaust gases to maintain intake pressure at high altitudes. Thanks to this innovation, the PP-47 could sustain nearly full engine power at 27,000 feet, an altitude where many European engines began to falter. Technically, it was the combination of a rugged airframe and consistent power output in the stratosphere, an advantage that few enemy fighters could match. The result was a fighter capable of maintaining speed and climb while converting kinetic energy into devastating high-speed dives, a strength pilots would later turn into a defining tactic. Engineering power required an industrial base to turn blueprints into mass production, and America possessed that capacity. Official production numbers revealed the staggering scale. 15,680, 3 P-47 seconds were built during the war, making the Thunderbolt the most produced single-engine fighter in the United States. At the Farmingdale plant on Long Island, assembly lines achieved a pace of 1 aircraft per hour, operating continuously to meet front-line demand. In Evansville, Indiana, a factory built on former farmland reached a rate of 500 planes per month by 1944. Each P-47 was not a single solid body, but an assembly of 65,000 individual parts, with wiring stretching up to 8 miles per aircraft and roughly 2,000 pounds of aluminum machined into structural components. These figures represented not only production capacity but also a complex logistics network linking component factories, assembly plants, and spare parts depots across England and France. The Thunderbolt's resilience came from its deliberate reliance on mass and material as safety measures. The wing spars were reinforced for extreme stress, and joint structures were designed to disperse impact energy. Engineers calculated bullet resistance, placing armor plates strategically around the cockpit and control systems to protect the pilot and maintain flight control even under heavy damage. This industrial-grade approach reflected a clear philosophy. It was better to overbuild than to risk fragility, better to add weight in exchange for repairability and survivability. It was a philosophy of industry, distinct from the European obsession with minimizing weight for agility. Logistics and supply chains were the key to turning a strong design into an effective weapon of war. Each P-47 mission carried 3,400 rounds of .50 caliber ammunition distributed among 8 Browning machine guns, giving it a decisive firepower edge over most adversaries. Those 3,400 rounds weighed nearly 900 pounds, requiring a sophisticated feed system with 8 independent ammunition boxes, powered conveyors, and acceleration mechanisms to prevent jamming under violent maneuvers. Ammunition demand was not merely a number, it represented a global supply chain stretching from munitions, plants, to logistics depots and Atlantic convoys. By mid-1944, total ammunition consumption by the P-47 and other heavy fighter units reached about 10 million rounds per month, a figure that mirrored the vast industrial machinery behind the front lines. Fuel was another logistical challenge. The Thunderbolt's consumption varied by mission, roughly 100 gallons per hour on patrol, rising to 300 gallons per hour in combat with supercharger and auxiliary systems engaged. The 9th Air Force alone reported a total fuel consumption of around 25 million gallons per month by late 1944. Such massive demand required an integrated maritime transport network, storage facilities, and port-side refueling systems to support operations in England and France. Every fuel shipment, every tank car, and every storage depot formed a vital link in maintaining thousands of sorties each month. The transformation from design to weapon of war also depended on people and process. P-47 production plants mobilized a vast workforce, many of them women entering the aviation industry for the first time. They learned to assemble engines, align control systems, and ensure every aircraft left the line combat-ready. High assembly speed demanded standardized components, interchangeable parts, and strict quality control. Manufacturing 65,000 parts for a single aircraft was only possible because the supporting industries worked in complete synchronization, from foundries and machine shops to electronics factories and technical training. Schools. Ultimately, the industrialization of warfare through the P-47 was not just a matter of output or consumption figures. It was the embodiment of a strategic belief. Victory could be multiplied through production, supply, and replacement. When one aircraft was lost, factories could deliver many more. When an engine failed, spare parts depots allowed rapid repairs. The Thunderbolt, therefore, was not merely the creation of Kartveli, it was the product of a vast industrial ecosystem, where every number from 9,900 pounds of empty weight to 15,683 units produced was a link in a chain of sustained dominance. In a war where resources became weapons, the P-47 stood as living proof of the power of mass production. The summer of 1943 marked the first turning point when the P-47 Thunderbolt was no longer a laughingstock in the skies over Europe. After months of testing and tactical refinement, the United States Air Force began to regain control of the airspace at altitudes the Luftwaffe had once considered its exclusive domain. At 30,000 feet, where the air was thin and ordinary piston engines faltered, the Thunderbolt maintained nearly full power thanks to its turbo-supercharger system. Meanwhile, the German Fw-190 and Bf-109 fighters began to lose breath, their climb rates dropped sharply, and their thrust weakened. German pilots who had once felt confident commanding these heights now realized their new adversary could sustain stable speed throughout patrols, something never before seen in previous years. From mid-1943, the boom and zoom tactics of Hubert Zemke and the 56th, 61st, and 62nd Squadrons proved highly effective. The Thunderbolts climbed thousands of feet above their opponents, then dove at over 500 miles per hour, fired for a few seconds, and pulled back up, leaving the Fokker-Wulfs below bleeding energy as they struggled to give chase. This advantage came from the combination of the R2-800 engine's power and the turbocharger's ability to maintain pressure. German engines, when passing 25,000 feet, often lost up to 40% of their power due to low oxygen levels. This difference forced the Germans to admit on the battlefield that the advantage of altitude had shifted entirely to the Americans. During B-17 escort missions deep into French airspace, formations of Thunderbolts formed a solid canopy at altitudes German fighters could not reach in time. American pilots could choose when to strike diving from above at speeds beyond their enemy's limits, firing, then withdrawing before the Germans could react. Many reports recorded that the Fw-190s meeting P-47 seconds at 30,000 feet nearly lost all tactical initiative. For the first time since 1939, the Germans no longer held air superiority. On October 8, 1943, one of the Luftwaffe's finest pilots, Oberleutnant Hans Philipp, credited with 206 victories, was shot down under such circumstances. That morning, he led Jägerschwader 1 on a bomber escort mission when they encountered a group of P-47 seconds from the 56th Air Force. The battle took place above 30,000 feet, where the BMW-801 engines of the Fw-190s were barely functioning. Robert S. Johnson, the same man who had survived the June 26th battle, wrote in his report that he saw an Fw-190 with distinctive nose markings diving toward a B-17 formation. When the moment came, he opened fire at 300 yards with a 30-degree deflection angle. The 50 caliber rounds struck along the German plane's fuselage, and it exploded in mid-air. No one knew exactly which bullet ended Hans Philipp's life, but it was the heaviest blow to the Luftwaffe's morale since the beginning of the war. Philipp was no novice. He had survived hundreds of dogfights across both Eastern and Western Europe, and was regarded as one of the Luftwaffe's spiritual pillars. When he was shot down, the report sent to Berlin forced High Command to convene an emergency meeting. From an enemy mocked only months earlier, the Thunderbolt had now proven capable of downing the Luftwaffe's best. In November 1943, a classified report was submitted to Reichsmarschall Hermann Göring, head of the German Air Force. Its content was described as the most troubling since the war began. The report detailed the P-47's performance through data collected from the front lines: a maximum ceiling of 42,000 feet, dive speeds approaching Mach 1, armor plating 3/8 of an inch thick around the cockpit, bulletproof glass 1/2 an inch thick, and a damage tolerance 3 times greater than that of the Fw-190. Technical officers concluded that 20mm cannon shells were no longer sufficient to penetrate the main armor, and that it took at least 2 coordinated pilots to bring down a single Thunderbolt. The summary sent directly to Göring contained a highlighted note: engaging this aircraft at high altitude is impractical. Many within the Luftwaffe regarded it as the first official admission that they had lost air superiority. Internally, commanders proposed developing a higher performance variant, the F-190A8, but engine upgrades ran into Germany's technical limitations. While they struggled with modifications, the P-47 continued to evolve. In early 1944, Republic Aviation introduced the new P-47D-22 variant, equipped with a 13-foot diameter Hamilton Standard paddle blade propeller. This design increased climb rate from 2,200 to 3,000 feet per minute, nearly a 30% improvement. More importantly, it completely altered the Thunderbolt's signature sound. When the blades spun at high speed, their tips reached supersonic velocity, producing a deep, thunderous roar. German soldiers on the ground described the sound as Donnerschlag, meaning thunderclap, a symbol of death from above. The same pilots who once mocked it now grew afraid. Each time they heard the combined roar of the R2800 engine and the screaming propeller, they knew the 50 caliber storm was coming. Field reports recorded that panic often spread among German ground units whenever the thunderous sound was heard, as it heralded precise, devastating attacks. Beyond physical might, the Thunderbolt had become a psychological weapon. The P-47D-22 was not only more powerful but also more versatile. With the ability to carry auxiliary fuel tanks, it began escorting bombers deeper into German territory. The combination of extended range and superior climb rate forced the Luftwaffe into a defensive posture. German fighters taking off from central bases such as Hanover or Frankfurt could not reach comparable altitudes before being detected and intercepted. Within months, Luftwaffe losses spiked, while the Americans recorded increasingly successful escort missions. This transformation was not the result of a miracle, but of industrial strength. As the P-47 was upgraded, thousands of components were reproduced and replaced directly in Europe, ensuring that every squadron could modernize quickly. The Luftwaffe, by contrast, suffered from shortages of materials, fuel, and experienced pilots. By the end of 1943, many German units were forced to deploy rookies with fewer than 100 flight hours. Meanwhile, the average American pilot had over 400 hours of training, including more than 100 hours on the very aircraft they flew in combat. From December 1943 into early 1944, the skies over Western Europe began to change color. Thunderbolt squadrons appeared in dense formations on clear days, creating a high-altitude shield for strategic bombing missions. Each time an Fw-190 or Bf-109 tried to climb, they were driven back down by Thunderbolt dives at blistering speeds. German pilots, once proud of their precision flying, now had to admit they were facing an enemy that conventional tactics could not counter. The Thunderbolt's aerial counter-offensive did not happen overnight. It was the culmination of months of combined science, industry, and training. As the Luftwaffe weakened at high altitude, the U.S. Air Force fully exploited this advantage to prepare for the next stage, airspace domination, and the lead-up to the Normandy campaign. Every flight, every dogfight contributed to establishing a new reality. The era of German domination in the skies was over. When the Donnerschlag roared from afar, German soldiers on the ground knew the storm of steel was approaching. To them, that sound signified defeat. To American pilots, it was the echo of confidence and the triumph of industry. The air war was no longer a contest of pilot skill, but a race between two systems, one built on experience and pride, the other on technology and production. And in the skies of the winter of 1943 to 1944, that balance had tilted decisively toward the Thunderbolts that carried the thunder of America. By early 1944, the air war over Europe had entered its decisive phase. The United States Army Air Forces needed an aircraft capable of protecting B-17 and B-24 bombers during deep penetration raids into German territory, where the Reich's factories, ports, and oil refineries were still operating. The P-47 Thunderbolt squadrons, once limited to missions over France, were now equipped with auxiliary fuel tanks, 108 gallons under the wings, or 75 gallons under the belly, extending their range to 1,000 miles. This transformation turned them into the first line of defense for the strategic bomber fleets, and from March 44, the P-47 seconds began escorting B-17 flying fortresses deep into Germany. When flying alongside the bombers, the Thunderbolt pilots' duty was not to attack but to hold positions above and beside the formation. They formed a living shell of steel, ready to dive at the first sign of German aircraft approaching. Previously, B-17 missions had suffered severe losses on some days. More than 25% of the aircraft failed to return. But once the P-47 seconds began escorting the entire route, the bombers' survival rate rose by over 40%. In April, several deep raids into Berlin and Schweinfurt returned with record-low losses. The 8th Air Force Command recorded that the appearance of the Thunderbolt signaled the end of the Luftwaffe's free reign over the German skies. However, with the introduction of the P-51 Mustang and its superior range, the Thunderbolt's escort role gradually shifted to another mission. Instead of flying high to protect the B-17s, the P-47 was refitted to become a ground attack aircraft, the most powerful close support weapon the Allies would ever possess. With its reinforced airframe and resilient engine, it could carry two 1,000-pound bombs under the wings and another 500-pound bomb under the belly, matching the payload of an early war medium bomber. In addition, new racks for 10 5-inch HVAR rockets allowed the P-47 to penetrate tank armor. From the spring of 1944, Thunderbolt squadrons began intensive training in ground attack tactics. Pilots learned to dive from altitudes between 6,000 and 8,000 feet, aiming directly at convoys, trains, or fuel depots, then pulling up after dropping bombs or firing rockets. Each attack lasted only a few seconds, but the destruction was enough to turn an entire convoy into a sea of fire. The 12.7mm bullets pierced light armor, while the bomb blasts shook the earth. When a P-47 pilot pressed the trigger, 8 Browning machine guns roared at once, creating a wall of fire so dense that the Germans called it the Steel Rain. On June 6, 1944, the Normandy landings began. Over the skies of northern France, More than 500 P-47 seconds of the 9th Air Force flew in layered formations, covering the entire landing zone. From dawn onward, they struck relentlessly at German reinforcement routes, cutting off every convoy attempting to reach the beaches. Pilot Robert L. Basler of the 325th Squadron recalled that from 10,000 feet, he could see the coastline shrouded in gun smoke and explosions, while on the radio, American ground units kept calling for help. "Thunderbolt, we are under artillery fire from Kane direction, requesting support." Minutes later, flights of P-47 seconds appeared, raining fire down on the marked targets. For the Germans, the sky that day was a nightmare. A report by Lieutenant Wolfgang Fischer, pilot of Jägerschwader II, recorded that his unit tried to take off for interception, but as soon as they climbed, they saw P-47 seconds stacked in layers. He wrote, "12 of us took off. I was the only one who came back. Their guns thundered like storms. Our planes disintegrated in mid-air. The Luftwaffe lost nearly every aircraft attempting to reach the landing zone that day, a loss from which it never recovered." After D-Day, the Thunderbolt's role expanded across the entire Western Front. Each squadron was assigned its own sector to sever German supply lines. Factories, fuel trains, bridges, and convoys became primary targets. The P-47 not only attacked by day but also flew low-level afternoon sorties hunting trains. Many pilots later described scenes of miles-long railways torn apart by explosions and black smoke rising like clouds. They called these missions milk runs, referring ironically to how easy it was to destroy unprotected convoys. The effectiveness of the Thunderbolt was most clearly reflected in the statistics of the 9th Air Force. In June 1944 alone, P-47 squadrons destroyed 651 locomotives, 3,847 trucks, 512 tanks, and 4,553 horse-drawn vehicles. Each number represented not just destroyed material but a broken link in Germany's logistics network. The direct result was that German forces on the Western Front lost their ability to resupply and maneuver, leaving their defensive units unable to react to the Allied advance. The accuracy of these attacks came from tight coordination between pilots and ground spotters. Forward teams equipped with radios in jeeps relayed coordinates to the passing squadrons. When smoke shells were fired to mark the target, the P-47 seconds dove instantly, released their bombs or rockets, then banked away before the anti-aircraft guns could rotate. Many pilots recounted that only a few seconds were needed to wipe out an entire convoy. A single HVAR rocket, equivalent to a 105mm artillery shell, could blow apart a Panzer IV tank. The intensity of P-47 operations during this period was so immense that maintenance crews had to work day and night. Each aircraft, upon landing, was refueled, its gun barrels replaced, and thousands of rounds reloaded before taking off again in under 2 hours. Despite the heavy bomb and rocket loads, Thunderbolt's mechanical failure rate remained extremely low thanks to its sturdy construction. Its resilience allowed many aircraft to return even after taking severe flak damage. There were cases of P-47s landing with one wing partially broken and a burst tire, yet the pilot survived. The psychological effect the P-47 had on German troops went far beyond statistics. Soldiers on the ground began calling it by names like Jarbo or Fliegender Tod, the Flying Death. When the distant roar of the R-2800 engine was heard, German troops knew that any attempt to move during daylight was futile. Supply convoys shifted to nighttime operations, but even then, their efficiency dropped dramatically. A logistics report from the German 7th Army stated, "During daylight, all movement must cease. Every engine sound in the sky sends men running for cover." Across northern France, fields, railways, and small towns all bore the scars of Thunderbolt firepower. After the war, historians estimated that 9 out of 10 German tanks destroyed in the Normandy area had been hit directly or indirectly by airstrikes. From an aircraft once considered too heavy for combat, the P-47 had become the most efficient destruction machine the Allies possessed. When the German army was forced to retreat across the Seine at the end of August 1944, the P-47s pursued relentlessly, striking pontoon bridges and retreating columns. On Allied command maps, the zones where transport networks were obliterated were marked with the symbol T-Bolt. It was more than just the mark of an aircraft, it was the emblem of how America waged war, through technology, numbers, and endurance crushing its enemies. The ground battlefield in Europe in 1944 was reshaped by the thunder of the R-2800 engines. From escorting B-17s high above the clouds to sweeping through convoys on the earth below, the P-47 had proven the worth of a design made for total industrial warfare. As the bomb smoke slowly cleared over Normandy, the silver wings still passed overhead, glinting in the afternoon sun, carrying the signature rumble the Germans called Donnerschlag, the sound of an empire collapsing. By the end of 1944, as snow began to blanket the German plains, a new silhouette appeared in the skies over Europe, the Messerschmitt Me-262, the first jet aircraft to enter combat. With a speed exceeding 540 miles per hour, it was faster than any piston-engine fighter the Allies possessed. The Luftwaffe placed its last hopes on this weapon, believing that jet technology could reverse the tide of war. But in reality, technical advantage could not save a force already drained of pilots and fuel. The Me-262 required long runways. Its Jumo 004 jet engines were fragile, and they took several minutes to accelerate, leaving the aircraft highly vulnerable during takeoff and landing. On November 27, 1944, Lieutenant Colonel John C. Mears of the 352nd Squadron spotted a Me-262 attempting to depart from a base near Osnabrück. Flying at 28,000 feet, Mears rolled his plane inverted and dove at nearly 500 miles per hour. At 400 yards, he opened fire. 8. 50-caliber machine guns thundered together, their heavy rounds raining down on the German jet. In his post-battle report, Mears wrote, "The enemy aircraft disintegrated, both engines separated from the fuselage, no parachute seen." It was one of the first instances of a P-47 shooting down a jet fighter and a symbol of the boundary between two eras. The age of piston engines was closing, but the spirit of the Thunderbolt stood firm before the dawn of new technology. In the final months of 1944, the number of Me-262s in combat remained far too small to make a difference. Germany produced fewer than 1,400 in total, but only about 200 ever saw combat. The P-47 and P-51 squadrons, through tight coordination and superior maneuverability at low altitude, found an effective counterattack when the German jets were taking off or decelerating to land. The Me-262 could fly faster in the air, but it could not climb to combat altitude quickly enough to evade an ambush. Many American pilots recalled that whenever they saw black smoke from a jet's engines, they knew opportunity was near. Germany's speed advantage became a burden without the fuel and logistics to sustain it. As P-47 squadrons expanded their operations across Western Germany, the Luftwaffe prepared for one last desperate gamble, Operation Bodenplatte. On the morning of January 1st, 1945, over 900 German aircraft, including Fw-190s, Bf-109s, and a few Me-262s, launched a surprise attack on 17 Allied airfields in Belgium, the Netherlands, and France. Their objective was to destroy as many aircraft on the ground as possible, hoping to temporarily regain air superiority for the Ardennes counter-offensive. The assault began at dawn, with fog blanketing the ground, allowing German pilots to approach undetected. At Metz Y-34 base, home to the 365th Thunderbolt Squadron, explosions erupted just minutes after the first wave appeared. Within half an hour, 22 P-47 seconds were burned, and several hangars and runways were destroyed. Witnesses recalled Fw-190s flying so low their wheels nearly grazed rooftops, firing relentlessly along rows of refueling aircraft, but the joy was brief. As the smoke still rose, nearby bases sent emergency signals, and reserve squadrons scrambled to counterattack. Many Fw-190s were shot down during their retreat. Within 48 hours of the raid, American factories and supply depots had already delivered replacement P-47 seconds. At Metz, as engineers cleared the wreckage, a captured German officer watched the line of newly arrived Thunderbolts and laughed bitterly. You lost 20, and they replaced them before we even got home. That story quickly spread through Allied squadrons as a testament to American industrial might. While the Luftwaffe lost 271 aircraft and 213 pilots, many of them veteran instructors and commanders, the Allies lost 134 planes, all replaced within a week. By the winter of 1945, the Luftwaffe was nearly incapable of recovery. They were so short on fuel that many airfields could launch only a few sorties per day. Seasoned pilots were dying, and recruits entered battle with fewer than 100 flight hours. By contrast, P-47 pilots averaged over 400 hours of flying time, including more than 100 hours directly on the Thunderbolt. The balance of experience and skill leaned entirely toward the Americans. Wherever German troops moved by day, P-47 seconds appeared overhead, raining bombs, rockets, and machine gun fire. By April 1945, 9th Air Force statistics showed that Thunderbolt squadrons had shot down 3,752 German aircraft in the air and destroyed another 3,315 on the ground. The numbers for ground vehicles exceeded all predictions. 86,000 rail cars, 9,000 locomotives, 6,000 tanks, and tens of thousands of transport trucks. Each Thunderbolt sortie contributed to the paralysis of Germany's entire logistics network. German forces were forced to retreat only at night, crawling through the wreckage of their own infrastructure. When historians later analyzed the war, they concluded that no army in World War II suffered logistical destruction as severe as Germany's in 1945, and much of it was due to the Thunderbolt's firepower. On the ground, German soldiers began referring to the low, rumbling engines as the harbingers of death. Many described the terror of hearing the thunderous roar of a P-47 diving from above, the sound they called Donnerschlag, meaning the Thunderbolt strike. For German artillery and tank units, it was the signal to abandon vehicles, take cover, or feign death in open fields. No form of anti-air defense could stop it. Even the famous 88mm flak guns could not traverse fast enough to follow a Thunderbolt's dive. By March 1945, with Berlin only weeks from collapse, the surviving Luftwaffe pilots knew the war was over. Many were haunted by memories of 1943, when they had laughed at America's new fighter. Joseph Pips Priller, former commander of Jagdgeschwader 26 and one of the first to encounter the Thunderbolt 2 years earlier, wrote in a personal note, "We laughed. Those fat machines looked so clumsy. Now no one laughs. They lose 10, they build 20. We lose 1, and it's gone forever." That confession captured the tragedy of the Luftwaffe. In 2 years, from Europe's pride, they became a force that existed only on paper. The remaining pilots flew aircraft lacking parts, ammunition, and sometimes even fuel to return to base. The Americans, meanwhile, patched bullet holes, refueled, and sent their Thunderbolts back into the air the next morning. The aircraft had become a symbol of an America that could produce faster than the enemy could destroy, repair quicker than the enemy could replace. When the war ended, the P-47 was seen as the embodiment of flying industry, representing the American philosophy of warfare using material, manpower, and technology to break the enemy's will. The Luftwaffe was defeated not only in the skies but also in factories, oil depots, and supply chains. Their downfall did not come from a single battle but from the millions of revolutions of R2800 engines and countless mass-produced 50 caliber rounds. In May 1945, as white flags waved over Berlin, Thunderbolts still patrolled the skies of Germany. They met no opponents, only the ruins of cities that had once stood proud. The Luftwaffe's final battle ended in silence, drowned beneath the steady roar of American engines, closing a chapter in history where human arrogance was buried beneath the might of industry and enduring resolve. When Berlin fell in May of 1945, the war ended not only with the collapse of an empire, but also with the psychological collapse of an entire generation of pilots who had once believed themselves invincible. Across Germany, in Luftwaffe medical camps, doctors began recording a strange phenomenon spreading among surviving pilots. They called it Jabberfieber, a syndrome of fear toward ground attack aircraft, especially the P-47 Thunderbolt. Men who had once fought through hundreds of dogfights now trembled whenever they heard a deep engine rumble outside a window or saw a shadow sweep across the sky. Some vomited uncontrollably, others fell into panic and prolonged insomnia. In Luftwaffe medical files discovered after the war, one note read, "Symptoms include rapid heartbeat, sweating, auditory hallucinations of machine gun fire, and reflexive ducking when hearing mechanical sounds. Common among frontline pilots exposed for extended periods to P-47s and P-51s. Jabo fever was not merely a physiological reaction but the result of 2 consecutive years of unrelenting despair. As Thunderbolts appeared in ever greater numbers, every tactical calculation Germany had collapsed. From above, from planes, from any direction, the P-47 could appear without warning. It needed no concealment. For the rumble of Donnerschlag, the thunderclap was itself enough to induce panic. That terror reached beyond pilots, spreading to soldiers on the ground. German troops called the Thunderbolt the Flying Death, and the phrase "do not go outside when you hear thunder" became a familiar warning along the Western Front. Later, military psychologists would regard Jabofeber as one of the defining examples of neurological trauma caused by modern warfare, where even the sound of an engine could become a weapon. While the Luftwaffe's spirit crumbled, the United States Army Air Forces recorded numbers never before seen in the history of aerial combat. By the end of 1945, the P-47 had downed a total of 3,752 German aircraft in air combat and destroyed an additional 3,315 on the ground. Counting vehicles and infrastructure, the Thunderbolt was credited with destroying more than 86,000 railcars, 9,000 locomotives, 6,000 tanks, 68,000 trucks, and tens of thousands of other vehicles. The P-47's air combat kill ratio stood at 4.6 to 1, meaning for every Thunderbolt lost, 4 to 5 enemy aircraft were destroyed. It was the highest ratio among all Allied fighters in Europe, surpassing even the Spitfire and the Mustang during the same period. What impressed historians even more was the Thunderbolt's remarkably low loss rate. With its thick armor and resilient radial engine, the P-47 could absorb punishment unmatched by any other aircraft. In thousands of sorties, many returned riddled with bullet holes yet landed safely. Republic aviation engineers estimated that a single P-47 could sustain damage equal to 3 ordinary fighters before losing control. The philosophy of firepower over finesse had proven itself true in practice. In a prolonged war, durability and endurance mattered more than speed or maneuverability. The P-47 was not admired for its looks but for its effectiveness. It was the embodiment of industrial warfare, the power to transform energy, steel, and labor into air superiority. As Thunderbolts flew across Europe, each burst from their 8 machine guns echoed the strength of the vast manufacturing system behind them. Every bullet, every gallon of fuel, every takeoff was the result of millions of hours of labor. In a 1946 article, aviation historian Arnold Kramer wrote, "The P-47 was not a masterpiece of art, but a masterpiece of the assembly line. It was not built to be beautiful, it was built to survive and to win." 40 years after the war, when veterans from both sides gathered at an international conference in Phoenix, Arizona, a calm, reflective German stepped to the podium. It was General Adolf Galland, former commander of the Luftwaffe's fighter forces, who had faced the Thunderbolt directly between 1943 and 1945. Speaking slowly, in German-accented English, he said, "We did not understand that the Americans did not build airplanes for individual victories, they built them for industrial war. When I flew a P-47 after the war, I knew we had lost in the factories." His admission was not only a gesture of respect for his former adversaries, but also a recognition of the philosophical gulf between the two industrial worlds. Galland recalled that when he entered the cockpit of the P-47, what struck him first was not its size, but its solidity. Every component felt thick, every switch firm, as if the aircraft had been designed to withstand the weight of the world itself. He remembered the deep vibration when the double Wasp engine came alive, the floor trembling beneath his feet. "I understood why American pilots survived so often," he said. "We built precise machines. They built enduring ones. In war, endurance wins." His words, recorded and widely circulated by journalists, were seen as an epitaph for the Luftwaffe era. After the war, many nations continued to operate the Thunderbolt through the 1950s from France and Brazil to Mexico. In smaller conflicts, it remained effective, proving the timeless value of a design rooted in practicality. In the United States Air Force Museum in Dayton, Ohio, a restored P-47D stands beside a photograph of Robert Johnson, beneath which reads, "We came back, even with 200 bullet holes." Below that is a quote from an anonymous German pilot, taken from a 1945 interrogation. "We laughed when we first saw them. In the end, none of us were left to laugh." The legacy of the Thunderbolt reaches beyond technology. It represents the philosophy of the democratic world, that strength lies not in individuals but in systems. Each P-47 embodied the collective effort of thousands of engineers, workers, pilots, technicians united toward a single purpose. That power came not from genius alone but from national coordination. While Germany placed its faith in exceptional pilots, America placed its faith in industry and process. That difference shaped the outcome of the war, and later became the foundation of modern military doctrine. As the world entered the age of missiles and jet propulsion, the philosophy of the P-47 lived on in every new design. Successor fighters from the F-86 to the F-15 inherited the principle that strategic advantage must come from industrial strength and production capacity. Aerospace engineers of the 1960s continued to cite the Thunderbolt as the classic example of reliability in wartime design. That spirit became part of the American industrial identity. When technology meets scale, no individual effort can stand against it. In the memories of surviving German pilots, the thunder of Donnerschlag remains unforgettable. It was the sound of technology, of mass production, of a new world where man and machine fused to create absolute power. For American veterans, the rumble of the double wasp meant something different, a reminder of teamwork, of faith in collective strength. Thus, the story of the P-47 Thunderbolt did not end over Europe in 1945. It endures as the symbol of an era when humanity learned that in modern war, victory does not belong to the lone hero. It belongs to the nation that can turn steel and willpower into its own sky.